Let's do something interesting in the sabermetrics track, looking at regression and the Pythagorean theorem. Now remember the Pythagorean theorem from Bill James. That's where winning percentage, which can also be written as wins over wins plus losses, total games played, equals or approximates runs squared divided by the sum of runs squared plus runs against squared. So this is the classic Pythagorean theorem, and I want to do a little algebra to transform this to a simpler form that will allow us to do a logarithmic transformation, run a regression, and find in any set of data the best term for the exponent to replace the square term. Let's do some algebra here. First thing we want to do is get rid of the denominators. So this is going to transform into the form like this. Wins times runs squared plus runs against squared, and I'll keep using the equal sign here, is the same as wins plus losses times runs squared. All I did was multiply both sides by runs squared plus runs allowed squared. That canceled this term and it stays on this side. I also multiplied both sides by the term wins plus losses, canceled on this side of the equation, and it shows up over here. Let's expand this out. So what we have now is runs squared times wins plus runs against squared times wins. We're just expanding out the formula. And then we get runs squared times wins plus runs squared times losses. This is just expanding the terms. The next thing we'll do is divide by runs squared. Divide everything by runs squared. Put a note over here, sort of divide by runs squared, so you remember what we did. What we did here was cross multiply each side by the denominator. And so when I divide by runs squared, what I end up with is wins plus RA squared times wins divided by runs squared. The runs squared here just cancels out. And this is wins plus losses. Both of these terms, the run squared drops out. If we subtract now wins from both sides, we just subtract wins from both sides, what we get is runs allowed squared over runs squared equals losses. What we do then is, oh, and there's a win term here. I forgot this. This stays up here, the win term. And now we divide both sides by wins, so we get runs allowed squared over runs squared equals losses divided by wins. And I can flip this around to make it wins divided by losses equals runs squared over runs allowed squared. I can square this term, and now I can put parentheses here, and now I've got the form that I really want to use in some R code to analyze the best way to do the Pythagorean exponent. So here's the formula. It's wins divided by losses, the ratio of wins to losses, is the same as the ratio of runs to runs allowed, that term squared. So hopefully we've convinced you with algebra that this equation is the same equation as what we started with, the Pythagorean equation, which is well known as winning percentage estimators, one of the winning percentage estimators. So we've talked about this before, but now we've transformed it into a new equation.